Symphony Environmental Technologes is a world leader in the development of additives to make ordinary plastic biodegradable and protective technologies to enhance plastic products. Now today we're talking to Michael Stephane, a main board director of Symphony Environmental Technologies Group. Michael, good morning to you.
Good morning.
Now Michael, before you joined the board of Symphony, you were a practicing barrister for 20 years and then a member of Parliament. While you were an MP, I think you were also a member of the Select Committee on the Environment. Did this have anything to do with joining Symphony?
Yes, it did in a way. When I was on the Environment Committee, I became aware of the dreadful problems caused by plastic waste, which did not get collected for proper disposal and escaped into the open environment all over the world. And we've all seen the television programs showing the plastic accumulating in the oceans. I became aware that Symphony had found a way to deal with this problem, so I was pleased when they invited me to join them after I came out of Parliament.
Brilliant. Now, plastic's got a really bad name these days. Do you think that's justified?
Well, yes and no. Like many non-scientists, I had not been aware that plastic is really a miracle of chemical engineering, which was invented by some very clever people. Just think, a plastic film only a few microns thick is immensely strong and durable, and it's not expensive to produce. I think it's the best material by far for protecting food and many other goods from damage and contamination, and for reducing food waste. It's much better than paper, especially if it gets wet. Now, in addition, and particularly important during this pandemic, so that Symphony has also found a way to upgrade plastic so that it kills bacteria and viruses, and perhaps we can talk about that another day. I think it's really unfortunate that plastic has been demonized in the last few years. We're witnessing an almost hysterical plastophobia, which is not good for human health or the environment, because the only thing wrong with plastic is that if it gets into the open environment at the end of its useful life, it can lie or float around for many decades, some people say for hundreds of years, before it becomes biodegradable. Now, as we all know, governments and NGOs, including Britain's Department of the Environment, have paid a lot of attention to this problem, and we know about their proposals for reducing, reusing, composting, and recycling. But there's a gaping hole in their policies. It must be obvious that you cannot reuse or recycle a product or take it to a composting facility if it's escaped into the open environment for which it cannot be realistically collected. And it seems to me that governments and NGOs are behaving as though this part of the problem did not exist. They're simply ignoring it. But fortunately for us, some of the scientists who were working with plastics in the 1970s were aware of this problem, and they found a way to make the plastic convert automatically into a biodegradable material at the end of its useful life. One of these scientists was Professor Gerald Scott, who patented the technology and later became Chief Scientific Advisor to Symphony. I had the privilege of knowing him at that time. But unfortunately, the plastics industry paid no attention to this amazing invention, and they continued to make ordinary plastic, which started to accumulate in the oceans and has now become a serious problem. But about 25 years ago, both the problem and the solution were noticed by Symphony's founder, Michael Stephane, and the company has developed Professor Scott's invention into one of its main technologies. It's now marketed in 96 countries around the world under Symphony's d2w trademark, and it's even been made compulsory in the Middle East. But still not everybody knows about it, even in the UK.
So how does d2w technology work?
Well, Symphony's scientists have put together a very sophisticated package of chemical ingredients, which they call a master batch, and this is put into the plastic products while they're being made in the factory. The master batch contains pro-degradant catalysts and stabilizers in exactly the right balance, so that during its useful life, the plastic product performs in the same way as an ordinary plastic product and can be recycled in the same way if it gets collected. And many thousands of tons have in fact already been recycled. This upgraded type of plastic costs little or no more than ordinary plastic. But the crucial difference is that if the plastic does not get collected and is left in the open environment, the catalyst will cause it to oxidize and to reduce its molecular weight so that it becomes a waxy substance which is no longer a plastic and can be consumed by microorganisms. And this is why it's called Oxo-Bio-degradable. It will convert automatically into biodegradable materials much more quickly than ordinary plastic would, and it will then be recycled back into nature by the bacteria and fungi who live in the open environment, leaving no toxic residues. And this has recently been confirmed beyond doubt by a 5-year study called the Oxo-Bio project, sponsored by the French government at their marine laboratory in the south of France. And the report was published in March of this year.
Okay. But some people are saying that you're creating microplastics.
Yes, I've heard that too. But in fact, almost all the microplastics found in the environment today are caused by the fragmentation of ordinary plastic after it has been exposed to weathering. And that is why it should all be upgraded with d2w technology at the point of manufacture. Ordinary plastic is oxo-degradable because it degrades in the presence of oxygen, but it does not become biodegradable except over a very long time. And by contrast, Symphony's d2w plastic is oxo-bio-degradable. Now, the European Commission asked their scientific experts, the European Chemicals Agency, to study oxo-biodegradable plastic in 2018 because the Commission thought that it created microplastics. We submitted a substantial dossier of technical evidence to the agency, and so did many other people. Then 10 months into the study, the agency announced that it was not convinced that microplastics were formed. And of course they are correct, because oxo-biodegradable plastic converts into a substance which is biodegradable and does not create microplastics in the same way that ordinary plastic would. So we were astonished when the European Parliament ignored the European Union's own technical experts and legislated to ban what they called oxo-degradable plastics. The problem is that they have legislated in such a way as to create confusion as to whether it also applies to oxo-biodegradable plastics. And the Commission is saying that it does. But that's only the opinion of the Commission and is not binding on member states or the courts. And the directive is not, of course, binding anywhere in the world outside the EU. And this ban is actually the subject of a legal challenge brought by Symphony against the European Union in its own courts. And perhaps we can talk about that another time.
Yeah, certainly. Now, you've said that plastic's very useful and that Symphony's found a way to prevent it accumulating in the open environment. But doesn't it require a lot of fossil resources to make plastic?
Well, not really, because oil is extracted from the ground to make fuel for engines, and plastic is made from a byproduct of refining that oil. It's called ethylene. Maybe there'll become a time when oil is no longer needed as a fuel for anything, but that's quite some time in the future. Until then, it makes sense to me to use the byproduct to make plastic rather than using scarce land and water resources to grow crops to turn into plastics. Some energy is, of course, required to convert the ethylene into plastic, but this is much less than the energy required to make paper, glass, steel, or aluminium, or to make plastics from crops.
Right. Now, Michael, you are chairman of the Oxo-Bio-degradable Plastics Association, as well as the director of Symphony, and you write a weekly column in Bioplastics News. Can you tell us more about that?
Yes, I used to write critical comments about articles in Bioplastics News, which I thought were mistaken. And one day I was surprised when the editor invited me to write a weekly column. I make it quite a controversial column, and the editor tells me that it's widely read by senior people in governments and companies all around the world. I'm happy to write this column because I think it's really important for the future of the environment that as many people as possible understand the issues that we've been talking about in this interview today.
Of course. Joining me today was Michael Stephane, the Director of Symphony Environmental Technologes. Michael, thanks for joining Directors Talk today.
Thank you. Goodbye.